Okay, so since we are still on the series circuit, so I showed you previously how to do the EMF. So I said for a series circuit, the EMF, you have to consider the internal resistance also. Okay, so I said EMF is equals to the sum of the voltages V1, V2, V3. So EMF is the sum of voltages across the circuit. So EMF, we can explain it as the potential difference or the voltage. So let me say voltage. So EMF, you know that EMF stands for electromotive force. So it's the voltage measured across the terminals of a battery when there is no flow, battery when there is no charge flow. So what they mean when they say there is no charge flow, you see the statement, no charge flow. No charge flow means you can simply replace that with the open circuit. So when they say a circuit is open, it means there's no resistor. Open circuit is something like this. Open circuit. Like, let's put a switch there so that you can see what does the open circuit means. So open circuit is something like this. When the switch is open, it's not complete. That's why they say it's an open circuit, because you see when it gets to the switch there, it breaks. It doesn't complete the circuit. So that's an open circuit. So when the circuit is open, it means there is no voltage taken from this battery. So meaning it's like your battery, like your phone battery. If you are not using it, it will last longer. But the moment you start pressing it, it closes the circuit because you are operating that phone. So that's when it uses the battery. But in order for you to get the total voltage, you don't have to use the battery. You just take out the battery from the phone, you measure it, you're gonna get a total voltage. But the moment you start closing the circuit, that switch, if you close that switch, the circuit is complete, meaning you're gonna take out the voltage, you're gonna drain that battery. So I was explaining the voltage, the EMF. So let's say you've got a circuit that is like this. I'm explaining. Let's say you've got a circuit with two resistors, R1, R2, and also the voltage there. This voltage, or you can say EMF. You see there, the voltage, the EMF will be equals to V1 plus V2 because it's a series circuit. So in a series circuit, you have to calculate the individual voltage. So you have to get that V1 there because they've got a voltage drop, different voltage drop, and V2 there. But current is the same in a series circuit. Current, same. So the current here is 2 amps. So it means the current for resistor 1 and the current for R2, they are the same, but the voltage are not the same. So let's draw a simple circuit of 5 volts. So do you see that? Do you see that the voltage that is there, R1, R2, the voltage that is at R1, which is your V1, and the voltage that is at R2, which is your V2, when you add them, they must be equals to 5 volts. So V1 plus V2, they must be equals to 5 volts. They must be equals to 5 volts. So remember, you're going to say 5 volts is equals to I1. Remember, there's a current I1 that is the same because it's a series circuit. I1 times R1 plus I1 times R2. I1 is the same, so it's a 2 amps. It's a 2 amps. So remember, in a series circuit, in order for you to get the total resistance, the sum, total resistance, or the sum of the external resistance, you're going to say R total is equals to R1 plus R2. That's when you calculate the series circuit, the total of that series circuit. So I'm going to show you just now. So I'm going to make this equal, the resistance equal. So we're going to have to start, because you've got current and you've got current and voltage, so you can calculate the total resistance. Ne? So you can calculate the total resistance. R1 plus R2 is equal to total. So you can say I1 is the common factor there with maths. We are using maths now. So it means R1 plus R2. Remember, R1 plus R2 is the total resistance, so you can simply replace it with the total. In a series circuit, you add the resistors, you add them. So you've got 5 is equals to I1 times RT, R total. R total is R1 plus R2. So R total will be equals to, because you know what is your I1. I1 is 2 amps. So R total is equals to 5 divided by 2. So you can just go to calculator. 5 divided by 2. You'll get a 2.5. Remember to write in ohms. Write it in the form of ohms. So a recap on this. For a series circuit, the voltage drops of every resistor is different. Every resistor has got a volt drop. Every resistor has got a volt drop. So R1 has got V1, R2 has got V2, but the current is the same. It's all of them, they've got I1. Then to calculate the total resistance of a series circuit, you have to add the two resistors, R1 and R2, to get a total resistance. So do you see that my total resistance is 2.5? Total resistance is 2.5. 2.5 ohms. So now from this 2.5 ohms, I can simply say my resistors, when I add them, they should give me 2.5. So we'll calculate the individual resistors on the next slide.